Good morning, everyone. My name is Mike Clark, and this is the DBA Virtual Chapter. I'd like to welcome you all and wish you all a Happy New Year. Thank you for coming. Today's topic is Azure SQL databases, Elastic Pool. And our presenter today is Kun Cheng, and our sponsor today is Hewlett Packard. And we'd like to give a shout out to HP for partnering with us. Technology makes these kind of forums easy to do, but there are overhead and expenses, and HP has partnered with SQL Pass and specifically the Virtual Chapter to help sponsor these and to allow them to continue. And we're very, very grateful for their participation and support. The DBA Virtual Chapter is one of many virtual chapters. Here's a screen with many of them on there. They go from technology to language to location to vertical business, whatever. And so if you have an interest to learn more in a specific subset of SQL, this is a way to do it. There's a Persian, there's a Hebrew, there's a Russian, there's a Spanish, there's in-memory, there's data architecture, there's many different ways to fill your head with things that are pertain to our job and our world professionally, and PASS is here to help with that. So if you have want any more information, if you go to sqlpass.org and click on the VC link, you can go and get more information and contact information about all of these. One other thing that PASS does is they sponsor an event called SQL Saturdays, and it's pretty much how the name is. It's everything pertaining to SQL on a Saturday. They're generally free, and they're around the world at different venues. The upcoming ones in the next month and a half, here's 4 different sessions from USA, Canada, for EMEA, Latin America, and APAC. So if you're in the US or any of these areas, book a ticket and go. I'm sure your boss will approve. If you want more information, if you go to SQLSaturday.com, they'll give you the full agenda and their breakout sessions and what topics are going to be shared at that particular event and who's going to be the speaker. It's a great time to learn as well as network and meet other SQL Server folks. And as we're trying to show you here, there's many things you can do to be active in the SQL Server community. And it's a great community. I really do enjoy it when I get together with SQL folks. It is a highlight of the time. Not that I don't have an exciting life outside of work, but you understand it's still good to get with folks that think like-minded and we can talk about stuff in the same consideration. And PASS is a volunteer-run organization, so if you have any interest in helping out and dedicating time from just a few minutes to much more, please go to sqlpass.org and click on I'd like to volunteer, and you get a lot more information about that. And we have a presence on YouTube. It's growing. We have thousands of actually hours of presentations on YouTube. Again, if you go to sqlpass.org, you get a much better presentation of what all those options are out there. You can stumble across them on YouTube, but if you go to sqlpass.org and register if you are not already a member, you get a really good index of what's there in the speakers. So it's a better index basically of what's available on YouTube. And just get involved. There's many ways to do that. I'm sure you're all familiar with that, and these slides are available. You can go to LinkedIn, Facebook, Twitter, or the PASS website itself. So to bring us to focus of what we're here about today we're here to learn from Kun, who's a principal PM at the Microsoft Cloud and Enterprise as part of the SQL CAT team. He's worked with big enterprise customers and vendors. He's worked with SQL Server on-prem as well as in the cloud. We're looking forward to learning more from Kun today. And with that, I will make you a presenter, Kun, so you can take the realm.
Okay.
There you go.
All right. Hope you guys can see my screen.
Yes, we can see it.
Okay. All right. Thank you, Mike. I will talk about Elastic Pool within the context of our SQL database today. So based on the pool Mike did, sounds like probably half of the audience already familiar with the Azure SQL database itself, which is a pleasant surprise. I've spoken in different venues in the past. Most time when I talk about Azure SQL database, either I got response, hey, I'm only knowing SQL Server. Tell me more about SQL Server 2016, or was people who already running Azure, actually they're more like a developer focused. So they're not necessarily SQL savvy per se. So I'm really glad to see the audience here having a fair amount of knowledge about Azure SQL database itself. With that said, quick intro of myself. I'm a PM on the SQL CAD team. I hope many people know about SQL CAD already, but this is kind of our overview of our missions. We work with the customers as in the sense of working together with customers on architecture design, lab engagements, performance tuning, scale out design, those kind of things. We also come to the community to share as much as we could. We have a blog site, and we're being there in the SQL Pass conference every single year, SQL Saturdays. And the third mission, which is a little bit maybe less known, is we actually sitting together with SQL developers. We're actually same building, same floor. Our neighbors are working, on different parts of the SQL Server products, both on-premise and Azure, SQL Server and SQL Data Warehouse, right? You name it. A few highlights about what we engage with. We have customers running SQL Server 2016 production before RTM. And we had this particular engagement. We had over 1 million batch requests per second on a single box running SQL Server 2016. SQL Data Warehouse, we have over 200 terabytes single deployment out there. And for SQL DB, this is a particular example. I was personally involved. It's ISV. They're hosting over 10,000 databases on Azure. They've been growing over 1,000 databases every month, right? So aggregatedly, the throughput of workload is pretty high. Over 50 million queries per hour across these databases. It's been growing as we speak. So I will talk about, as I was mentioning, about SQL database Elastic Pool. I want to. I'm not sure how many people are familiar with Elastic Pool, which is kind of one of the skills we offer for Azure SQL database. I'll see if I can have time. Looks like I have 45 minutes left. I'm hoping I can share a couple of customer stories as well. So what is Elastic Pool? So the overview, I just want to talk about what is Elastic Pool, why it matters. What is comparison with the I would call the standalone SQL databases on Azure. I'll talk about benefits, and also I'll share the summary of the learnings from those early adopters before Elastic Pool became GA. In the preview, early days of Elastic Pools, we have been working with some customer engagements. So I'm going to share some learnings. Most learnings still apply today, even in GA. So I think that's going to be beneficial for you guys to be familiar with this, some of those learnings we got from those engagements. All right. Let me go through in the presentation mode. Hopefully the screen is bigger. Apologize for forgetting to do that. So since maybe half the people are already familiar with Azure SQL database, so I want to talk about this concept of DTU, because for most people who are new to Azure or new to Azure SQL database, they're sometimes I get confused about, hey, what are you guys talking about, the DTU? Because if you look at our Azure SQL database skill offerings, we have basic and standard premium, and they all come with this tag called how many DTUs each performance level come with, right? So this is a different concept than what you typically use for on-premise environment. If you're running SQL Server 2016 on a box with, like, say, 2-socket, 16 CPU core machines, maybe a terabyte memory, right? You know exactly how much computer resources you have dedicated for SQL Server, right? You can configure how much memory, how many CPUs you can allocate to your SQL Server instance. So on Azure, since SQL databases are managed by Microsoft, we manage all the hardware, we manage all the VMs, we allocate a certain amount of resources at the database level, not at the SQL Server instance level. So we come up with this concept we call the DTU, database throughput unit, which is a bundled box with a unit amount of resources, from compute, which is CPU, to memory, to read I/O, to write, which is the log I/O. So each database will come up with this certain, for example, the basic database is the bare minimum, the smallest skill we have. It comes with 5 DTUs. In a sense, you can say, hey, with 5 DTUs, you can run 5 transactions or 5 queries per second, right? So this is not a whole lot, but still you get a sense of this is kind of the way for us to tell you how much resource you can get with this particular performance level. The way for you to monitor to see how many DTUs we can consuming at the database level, you can go to the portal. The database, if you click on database, I can show that later on in my demo, how much DTUs in percentage-wise have been consumed for that particular database over the last hour, over the last day, over the last week, right? So you have different time frame you can look at. Just be careful, whatever the metrics you see on the portal is percentage-wise. It's very similar as you would query against this system catalogs. One is in the master database called the sys.resource stats. The other one is the DMDB resource stats. They have different granular level. But anyway, so you will be able to see the percentage-wise how many DTUs been consuming. You can even drill down into how much percentage of the CPU, how much percentage of the I/O and writes, right, so on. So that's the way for us to govern the resources at database level, so you can get exactly the guaranteed amount of resources dedicated to that particular database. So that's the DTU. Now I talked about this already, right? Even today, if you go to the Azure SQL database portal, when you provision a database, if it's a standalone database, you will get anywhere from basic to standard and all the way to premium, right? Basic has 5 DTUs versus P15, on the other hand, has up to 4,000 DTUs. It's actually P15 is fairly new. We only did it probably a couple months ago. They all have different price and also have different resources associated with that, right, for each one of those performance level. So now that's been the case for the standalone databases, right? So if you look at the standalone database, you will get a predictable performance because all the resources are guaranteed for that particular database, and you pay for that. It works pretty well for customers who are running a database which has very I'll say predictable but also very consistent resource requirements. So if you look at the graph I'm showing here, some customers, or a big chunk of the customers or ISVs, when they run databases, they don't typically keep the database busy all the time. For example, if you have an S3 database, right, which will come with 100 DTUs, you rarely see any particular workload consistently, consuming 100 DTUs or maybe 90 DTUs all the time, right? You will typically see a varying pattern. But still, even you're not using the maximum capacity of that particular database, you still pay for that, right? So that's why we introduce the Elastic Pool, right? So Elastic Pool has been GA'd since last summer's over probably more than half a year now. But the concept here is typically for any customer or ISVs who need to host reasonable amount of databases, not a single database, probably more than 10. The more your database you have, the high chance you can use the Elastic Pool to share the resources, right? For example, in the graph here, you see on the left-hand side, the bottom here, if you have one single database, a typical workload, I'm using a particular ISV workload pattern here. Over the time, you see this DTU consumption, which represents the workload, how heavy the workload is. over certain time, sometimes they're consuming maybe less number of DTUs versus some other time they may have a spike consuming more DTUs. And when you have 4 databases, you start to see, hey, different databases might consuming different amount of resources at the same time, right? So that's why you see different spikes over a period of time. And when you increase from 4 to 20 databases, you start to see aggregatedly they're actually it's less spiky if you aggregate all the resource consumption together, right? So the concept here is we want to provide a way for customers or ISV SaaS vendors to more effectively group databases together so they can share the resources among them without wasting the DTUs or eDTUs we call for elastic pool among the database themselves, right? So if you look at the right-hand side, I have this simple diagram showing this blue box basically represents we call it a pool. You can understand as a group of databases. You can put a large number of databases inside a pool, and for each database, you can configure the minimum and the maximum DTUs per database. So it's going to be universal for all databases residing in this pool. And at the pool level, of course, at the very beginning, when you decide to put this database in the pool, you have to decide how many DTUs this pool will have to be shared across all the databases within that pool. So here is a kind of animation showing, hey, if you have lots of databases, and some databases may spike in this time, some other databases may spike in different time, right? So if you have a pool with a max configured to be shared, all of these DTUs across the databases, that'll be a very effective way for these databases to run without running into any performance bottleneck. I want to show this this simple table showing, the different offerings we have today. Very similar to standalone databases, we offer basic, standard, and premium pools. You get 2 gig as the per database limit. There's a storage limits, but also DTU limits, right? So the maximum DTU you can configure for a pool. I'm not sure if you can see my pointer, but these are the max per pool could be up to 1,600 eDTUs. With standard, you can get 3,000. With premium, you can get 4,000 eDTUs. And of course, you can. We also have to you have to configure the minimum. You don't need configure minimum per se. This is the smallest pool you can configure or provision today, which is 50 eDTUs for basic and standard, and 125 for the premium. And as I'm mentioning, there's storage limits as well. So for each database, it has its own limits. Basic 2 gig, standard 250 gig, versus premium 500 gig. However, at the pool level, this is also very important for people to understand. It doesn't matter how many databases you put in the pool. There's a limit at the pool level for storage as well. So what I list here is 150 gig for the basic pool, and almost 3 terabytes for standard pool, and 750 gig for premium pool. The reason the premium pool has a smaller storage compared to standard is because premium pool is using the premium storage. Sometimes you will hear people talking about XIO. It's very similar to Amazon provision IO. So you'll have a more IO throughput and less IO latency compared to standard or basic. Of course, I have the pricing here as well, so you guys are feel free. I can share the deck afterwards. So, but also this is public information. You pay for the DTUs you have in the pool instead of paying for individual databases within the pool. For example, if you have a pool, a standard pool, and you have 400 databases, for example, if you have 100 eDTUs to be shared across these 100 databases, you only pay for 100 eDTUs you have for the pool instead of paying for any individual databases. There's no database level cost associated with that pool. Now, if you want to put more databases in the same pool, you still maintain 100 eDTUs. For example, if you double the number of databases from 100 to 200 databases, the cost to you still remain the same. That means you still pay 100 eDTUs. You're not paying for extra 100 databases in that pool. So that's where this is more cost. There's more cost savings for customers or ISVs, using the ELS pool. In terms of how to use ELS pool, we support pretty much all the different ways. You can configure the pool on the portal with some of the demo, and also you can configure or manage the pools using T-SQL, PowerShell, or REST APIs. Here, I want to show a simple, maybe the hierarchy in terms of the way we provision, or the way you can see these ELS pools. If you're familiar with our SQL database today, if you go to the portal, you will typically see a logical SQL server, right? And you can configure or provision the databases within that logical server. The ELS pool also needs to be associated with a particular logical server. So you cannot create a pool and add databases from different logical servers. So each ELS pool needs to belong to a single logical server. However, within the same logical server, you can create multiple ELS pools. You can create standalone databases. You can also put database in the ELS pool, but all within the same logical server. And also you can move the databases between different ELS pools, or between the standalone and ELS pools, right? So all these operations are supported, and they're all online operation. So you don't need to take any database offline to make this change. We call it SLO change. So this is a summary of the benefits. As I was saying, we designed this ELS pool feature for customers, ISVs, who needs to host a large number of databases, because the reason I was mentioning, you can more effectively share the resources, the DTU, across databases, and only paying for the total amount of eDTUs instead of paying for individual database. That's the main cost-saving benefit you have. In terms of the performance, the databases within ELS pools that perform pretty much the same as the standalone databases. This is because, for example, if you have a standard pool with 200 DTUs and you configure all the databases to be maximum 100 DTUs, right? Every single database, they can spike to 100 DTUs, very similar to S3, that is singleton or standalone database. So there's no performance bottleneck because of the resource competition at all, right? They're sharing the resources, but not necessarily. If you configure the pool at the level which can sustain the spike of the individual databases, the performance is not going to be impacted by your neighbors in that pool. I already mentioned about this ability to move databases in and out of ELS pools. There's no downtime. You don't need to make any application code change. This is very simple, as you can do to manage a database from T-SQL or PowerShell or REST API. There's different ways for you to manage how do you want to provision, how do you balance the ELS pools within the resource limits you assign to these databases or the pools. In terms of the compatibility with the other features, ELS pool works pretty well. It supports most of the features we provide on Azure today, including ELS jobs, ELS queries. The only exception is the in-memory OLTP is not supported in the ELS pools yet. So if you move a database into a ELS pool, the in-memory OLTP feature is not available, which is available for standalone database if it's a premium database. So that's the main, I guess, the only exception we have. But it supports all the other same T-SQL surface areas like column store indexes, temp tables, all the other features standalone database support today. Pool database also support those features. And that includes the BCDR, the business continuity disaster recovery features, right? You can configure database to use the active geo replication, point-in-time restore, or geo restore. All these features are available to the Pool databases, very similar to the standalone databases. Here's a summary of the main learnings we had from those customer engagements I was mentioning. Again, SQL CAD, as part of the SQL CAD, we typically with the customers who are kind of early adopters or willing to bet their business on Microsoft, even when the features in the previous stage, right? So we had lots of engagements in that pools. A big chunk of those customers are actually ISVs because they typically bring a lot of databases to Azure. I want to highlight some of those learnings in a single slide, but there are some other smaller things, but less worthy to mention because most of the other some smaller things or bugs we encountered in the previous stage, most of this already being addressed in the GA. So typically we have run into the scenario where some ISVs, they provision a lot of the SQL Server, logical SQL servers, and they have a large number of databases, but they're spread across a large number of logical servers as well. As I was mentioning, each Elastic Pool needs to belong to a single SQL server, right? So if you have less dense database spread out across a large number of logical servers, and you want to have an Elastic Pool to group the database that belong to different logic servers, we don't support that today. So as a workaround or as a learning, there's a way to reduce the number of logical servers. That means you consolidate the databases into fewer number of logical servers, and you can provision those Elastic pools within the context of those logical servers. Second learning is the portal is great for smaller number of databases or smaller number of Elastic pools, but we have run into a scenario where ISV is running tens, thousands of the databases, probably more than 100 Elastic pools. Is getting very overwhelming if you go to the portal to configure or manage all these pools and databases on the portal. Because graphical user interface does have limits, right? So we typically find ISVs or these customers, when they manage large amount of databases, they would be better off using PowerShell or REST API to manage these databases. In terms of monitoring, the portal is a great way to monitor, at the individual database or individual Elastic pool level. We have seen some large ISVs adopting the system, the SCUM, the system center management packs for Azure SQL database. It's a great way for you for this management packs to help you to monitor some key metrics of SQL DB. I already mentioned my in-memory OLTP is not supported, but other than that, all the other features are supported. I also mentioned you can move databases in and out of pools, which is online operation. However, we do observe in certain cases the SLO change. That means when you move databases between the pools or between the standalone and the Elastic pools, the time it takes could be long, depends on how big the database is and how many databases you're moving, and sometimes it also depends on if you have the geo replication already configured for that particular database. So just be aware of this particular scenario. If you want to make sure it has less impact and you want to do this fairly quickly, you need to watch out how many databases you want to make the SLO change in a single batch. We also observed in certain cases, especially for the premium pool databases, if you make a SLO change, meaning meaning many moving databases in other side of the pool, you might see small performance degradation during that change. So if you have a mission critical database inside the premium pool, just make sure you understand the potential performance degradation, and if you can schedule that to happen during long peak hours, that would be ideal. Again, that means you have to know in advance. During the evening time, I'm idling. Most of my clients have gone home, and my databases are not that busy. That's probably the best time for you to make the SLO change in preparation for the next day when the business opens again, everybody comes back to pump your database again, right? So that's the main reason. But just be aware of this potential performance degradation, but also how long it may take to move databases. So with that, I'm going to do a demo on the Elastic pools. I'm not sure if that's a good point to pause for any questions you guys might have.
Excuse me, there are a couple. Let me run through those. Sorry, let me go to here. I do have them. Hold on here.
Sure. Yeah.
So when you're moving the databases between the different pools and also between the standard and the Elastic pool, how is this done that everything is online?
So underneath, actually, the pool, majority of cases, actually, there's no physical move. It's more like we mark it and basically standalone database or Elastic pool databases, we don't treat it specially in terms of the resource allocation and how it belongs to a particular server. It's the way how we can mark it so they can be grouped with other databases that belong to the same pool, right? The online operation, but in certain cases, for example, if we need to make increase the pool size and which goes beyond the current physical resource limit, then it may incur kind of data movement. But while we're moving the data, we still keep the original databases online. That means your application can still access it. Think about your on-premise SQL Server, right? If you need to, like say, upgrade your environment, and you still want to keep your existing application up and running, there's multiple ways, right? Think about, like say, replication. You can replicate data from your existing production environment to the new hardware until you get all the data moved, and then you can do a switch over, right, and point your application to the new environment. So we're doing something similar to that fashion. That means, we do this online operation, meaning your old existing database still up and running, while we're doing the backend data movement piece for you.
Got it. Then there's just a brief flip of a downtime to make it active.
Yes.
Okay.
Yes. Okay. So which is very similar to the standalone database, right? For example, if you upgrade from S1 to S2, you may experience a very short period of short time of the switch time, but that's very in most cases applications can handle that very easily.
Okay, one more question, and then we can continue with the demo. Is what is a recommendation? And it can be a high level, or we can push it to later in the discussion. Is what would be the recommendation for migrating a 12 terabyte database to Azure?
Okay, that's a great question. So this goes beyond Elastic pool because even standalone databases today, for example, the highest offering we have, which is P15, is supposed up to 1 terabytes for a single database. That's the size and limitation we have today. So if you do have a single database which is over 12 terabytes, we have worked with some customer engagements like that, right? First of all, we need to understand, how come we have a 12 terabytes, which is not very typical for most of the OLTP workload, but we realize some of the enterprise workload does have, more than terabytes data size. But more than often we find actually there's a way for customer to archive data or shard the data, right? We have worked with the customers. They're using the ElastiScale, which is basically a .NET API library for people to shard the existing database into multiple shards. For example, 12 terabytes can be sharded into 24, half terabyte databases. It does involve the schema change. That means you have to pick a sharding key to partition that database. And also application needs to be aware now you have to deal with 24 databases instead of a single database, right? But I do want to say, for a single database over 1 terabyte size, we do have improvements coming very soon to support more than terabytes in size. So if you have a particular scenario, a workload that does need to require over 1 terabytes, please ping me offline. We can discuss how we can work with you, maybe even in a preview fashion, how we can support more than terabytes database in size.
Okay, great. On with the demo. Thank you.
Yeah, cool. So I'm on the portal. So I have a bunch of SQL servers. Again, remember I was talking about ElastiPool is in the context of a SQL, logical SQL server, right? Here I have a bunch of the SQL servers. These are logical SQL servers. And I'm going to click on this server called demo pre-pool server, which you already provisioned. You will see 15 databases in this logical server, right? They all have provision as S3. Again, this is S3. This is standalone, one of the standalone database performance level, meaning it will give you 100 DTUs. You notice on the top you see this purple ribbon, but you can click here to view the recommended ElastiPool database pool for this server. This is the feature we added, when we created ElastiPool. But basically, system automatically detects that, hey, your server has multiple databases. You may consider using ElastiPool. Okay, in this case, it gives you some recommendation. We're saying, hey, these 15 databases, you probably can create a standard ElastiPool with 200 DTUs, and you will have a monthly savings over, $1,800 US, right? If you click on that, you will drill down into more details. In this case, you can see the configure pool is 200 ETU pool, 15 databases, but also you can see the cost, right? Again, this is based on how many DTUs you have for that pool, and we multiply that by how much dollar you need to spend for each DTU. We're not charging you per database; we're charging you for a pool. Now, if I click on that configuring the pool, it will show you more details. This will explain why we made a recommendation about 200 DTUs instead of 300 DTUs or 100 DTUs, right? So here you will see the right-hand side, you can see all these blue bars. Each bar represents a database, one of the 15 databases. This shows you actually over the last 14 days, this standalone database is how much resource they have been consuming. For example, this particular database, it has average, EDTU average is 12 DTUs, peak to 99, almost 100 DTUs, then almost max out what S3 can offer. That's the reason that this database was provisioned as S3, because it does need to have the consume up to 100 DTUs at certain points, but on average it's not consuming that much, right? See these green bars, it shows the average. So each database has much less average DTU consumption. By the way, this is very typical for lots of OLTP workloads, especially for some of those big ISVs. That's what we've been observing. Now, if you look at the left-hand side, this graph shows, hey, if I put these 15 databases in the pool with 200 DTUs, and you will see, hey, most of the time, you will see aggregated DTU usage is, maybe 150 to 200 level. And we do have a spike that goes beyond 200 eDTUs, right? So this will bring the question, you have to make a decision, say, hey, for that particular spike, I'm okay with that. This is not going to be the end of the world. I can still run my my Elias pool to support most of these databases in most of the time. And that particular spike, maybe during 5 minutes time window, I'm willing to let that particular database suffer in terms of performance, for that shorter period of time. That's okay. Then you can go ahead and create this 200 DTU pool and put all 15 databases in that pool, right? Of course, if you want to change that, hey, say I want to increase this pool size, you can do that, right? For example, I can create a 400 DTU pool. I can still put 15 databases. Of course, the cost for you will be higher. But if my SLA is to ensure all databases will never suffer in performance, never have a spike that cannot be supported by my database in terms of how many DTUs I can provide. You can do that too, right? So you do have the options here, but this is all based on the system recommendation. You can do this today on the portal. I'll give you this recommendation. Now, if I go back to my go back to my SQL servers. Now, let's say we made a decision and we decide to put this database in the pool. And what's going to look like once you have this pool, I'll show you here. I create a different logical server just for the demo purpose, but you still see these 15 databases in a group. I'll show you one of the pools I created is I believe this is a 400 DTU pool. Yeah, you can see there's a 400 eDTU pool I configured, and I put in all these 15 databases inside that pool. And you can see this graph basically shows over the last week what's my pool resource usage. Again, this is aggregated DTU usage across 15 databases, but they're all in the same pool. 400 DTUs, 400 DTUs, you can see at the maximum you're getting probably 75-ish% of the DTU. That's the spike we saw, for in the other scenario when we had this singleton standalone databases. But on average, they're consuming, anywhere between 50 or 55% aggregated, across all databases, right? So my pool maybe is still over provisioned, but at least I can support this occasional spike happening. Down here, actually, when you do another click through, this is actually useful for people to do a drill down to monitor at the individual database level what's the behavior once the database is inside the pool. You can see again, this is showing the DTU percentage consumption, right? And you can pick up to 5 databases on this graph to show all together. You can have less at the individual database level. Again, those databases showing this pattern about this kind of occasional spiking, but the average is much lower, right? So you can pick randomly 5 databases to show up in this graph, and you can examine at what time they had a spike and how it's behaving inside the pool. So I'm hoping this will give you kind of a sense of what's the pool for, why you can use the pool to share the resources, how that can save you the cost without paying for the performance penalty. Any questions on that before I kind of go through a couple of customer stories very quick?
Yeah, there is a question or two. Okay. One is you were showing how to do some analysis of the DTUs once you're in the Elastic pool. Is there anything that we could, any DMV or any recommendation that we could follow to run something on our on-prem databases to estimate what a DTU size we should have and so forth? How would we translate our on-prem workload to a DTU workload?
Yeah, so that's a good question. So I mentioned at the beginning of the presentation, we had a couple system catalogs, but these are only for the Azure. That means you already been running on Azure, like a standalone database. You can look at the resource usage and decide if you want to move the pool if you want to customize that logic instead of relying on our kind of a portal recommendation. But for the on-premise environment, we're working on a tool or utility to help people to make that decision. Basically give you a sense of how many DTUs you're gonna need. If you don't want to wait for the pool for that tool, there's an existing tool called the DTU calculator. I think it's developed by one of the SQL MVPs. If you do a Bing or Google for DTU calculator, you're probably gonna find that tool. I think it's very simple to collect on-premise CPU, I/O information and do a translation in terms of how many DTUs you need to provision a particular database on Azure to support the same workload as your on-premise environment. Any other questions?
Sorry, yeah. One follow-up question to that. So you say you go through and you figure out you estimate your DTU is going to be X, and you move to Azure, and it turns out to be Y, and it's much bigger. Is there how do we go? I'm thinking more of the pricing thing, right? Because I know like back when we first got cell phones and stuff like that, if you went over your limit, you really got penalized financially. And then eventually they learned that people didn't guess right, or they didn't know all the little ins and the outs, but they often gave me credit for when I called in and say, hey, this happened. And then eventually they would say, if you got close to the end of your threshold or your limits, they would call you and say, hey, you're getting close to limits. Do you want to change to another plan? Or they would say, you went over in last month's plan. Do you want to go over this? We won't overcharge you because you went over, but you're going to have to move up, kind of thing, right? How do you have anything like that for this? Because it's hard to get it right. This is, it's a tough thing to.
Yeah, I totally agree. So when you, like I said, when you, especially for people moving from on-premise to Azure, when they don't have any idea how many DTUs they're consuming, we have seen some customers that blindly moving to a particular skill. For example, they're moving to P1, hoping it will support all the give you the same performance as the on-premise environment. Now, if that doesn't really pan out, for example, P1 has a fixed cost. That means when you provision that particular database, you're paying for the fixed cost of that particular database. And you can make a decision yourself if you want to move up to, let's say, P2, which basically double the cost of the P1, right? If you found that, hey, P1 is not sufficient enough, or that particular database in the pool, which you configure as 100 DTUs, you think is not good enough, you need to upgrade. So the decision is going to be up to customer to make. You don't need to overpay for that. We do have some improvements, not for SQLDB, but Azure overall in general, to give a customer ability to manage at the subscription level how much cost you are willing to incur, for all the deployments you have within that subscription, right? That means, you would allow your team to provision, a bunch of databases, a lot of the cloud services, and you will never go over that quota you set for that particular subscription. But database level, I think it's fairly straightforward, because once you upfront, you know exactly how much you're going to consume when you provision either a standalone database or elastic pool. You know exactly how much you're going to pay.
Okay, sounds good.
All right. Well, to respect the time, I don't think I'm going to have enough time to go through all of these scenarios, but I just want to mention this, maybe the first customer. It's called Mfiles, it's ISV. Let me see, maybe I can show you a couple of diagrams. Maybe it's too complex here to explain, but anyway, so this ISV is running a multi-tenant workload. That means for each their tenant, they have a single database. So they end up with a large number of databases they need to manage for their tenants. Each tenant has their own SQL database, but also have their own the file storage, has its own credentials. So this is a multi-tenant, but it's isolated at the database level, at the file level, at the security level, right? So there's no cross crossing between those tenants to protect the confidential entity of these tenants. So this is their scenario when they using the ELIZA pool. Again, the reason for them to pick ELIZA pool is because they have seen these patterns of single tenant. They might have some spikes, certain point of time throughout the day, but they don't want to pay for those spikes. But also they want to support the same performance level even when they have those spikes, right? So this way for them is they provision the ELIZA pools and then put all databases inside the pool, and they get much effective resource sharing across the databases, and their cost savings. I think they do have cost savings somewhere here. Yeah, so premium ELIZA pool, they're paying this much. When before the pool, they're paying this much, right? So they see the 13 times cost difference when they make a decision to move this premium databases into the premium pool. They also, there's another alternative, saving less, but this is where if they provision the singleton databases as S2, which is much cheaper than P1, they pay less, but the performance is not going to be as good as the premium ELIZA pool databases, right? So again, the point here is Mfiles, they found using ELIZA pool, they're getting the same performance, they pay much less than what they paid before. So I'm going to stop there, just make sure I cover any remaining questions given the time we have. But I think we're going to share the deck afterwards, so you can feel free to read the deck and ping me if you have any further follow-up questions.
Okay, there are no follow-up questions at this point. I think we've covered all of them up to now. So you are free to carry on and close up or continue.
Okay, all right, that's good. In terms of time, I mean, it's okay for me to go over one more custom example, or go over, or it's
one would be fine because we did we shifted to start, so that would be fine.
Okay, just want to make sure I give a shout for this another customer. This is a CAD engagement as well called GEP, headquarters in New Jersey. They're another example like Mfiles. They're ISV, so that means they're running multi-tenant application. Their business is really about this procurement. So think about these manufacturers. Vendors or even e-commerce kind of customers. They need to maintain or control this supply chain, support the procurement stuff. So this is what they do. So this is the pictures they shared with us. In the past they run their own data centers, right? So these are the hardware they had. Once they moved to Azure, they got rid of all this hardware stuff. By the way, we do have a case study with them, so I think I have a link somewhere. Yeah, there's a case study. Feel free to check out the details. But this is one of the architecture diagram to explain how they use Azure today. Pretty much all the components, including the SQL, including traffic manager, including a bunch of the stuff. They also bring from a third party, which they can hosting those VMs as IaaS. But their story of using ELIZA pool is very similar. They've been experiencing or have been observing this kind of workload patterns throughout the day. They're using New Relic in this case to monitor how much traffic are going through their web services. They're saying, hey, during the day, my web application users are pretty busy. They have this elevated kind of throughput or transactions going through. But that actually does not translate into the spike behavior. Sometimes they see after hours, when they have a special event going on, they see this the resource consumption spike happening after hours. Right. So to solve that problem of the spiking behavior, pretty much at any point of time throughout the day, they group into the database into the pool, multiple pools, and clearly closely monitoring the resource usage. So even during the off-peak time, they thought it's off-peak time, but they might have the spikes. The ELS pool can still support those workloads with the spiking behavior. So very similar story, but the point here again is for any customer ISVs who have multiple databases, and all those databases may not spike at the same time. That means they're not predictable, consistent, resource-consuming type of workloads. They probably can use ELS pool to share the resources among them, give customers the cost savings, give them the consistent performance without sacrificing any of the features with supporting SQL Server standalone databases. So, of course, GP, also has some cost savings numbers, this kind of things, right? So that's one of the main benefits we have. So with that, I just conclude my presentation. Again, this deck will be shared afterwards. Feel free to ping me afterwards with. Mike is still there? I can't hear
Yeah,
you.
yeah. So I'm here. Yeah, I'm here. Yeah, you were cutting out. I wasn't sure if you were coming back in or not. Okay. I want to thank you, Con, for your presentation. I've not really done much with Azure. I've read about it and friends with some folks that have used it, but this was actually pretty nifty to see how it works and how there is some flexibility and how this is improving over time. That's great. So with that, I'd like to
Yeah.
thank everyone for coming today. Thank you for the good presentation. Thank you, folks, for the good questions that have come in. With that, we're going to conclude today's session. And I'd like to remind you that in 2 weeks from today at noon Eastern Standard Time, which is 9 p.m. Pacific Time, there'll be another DBA Virtual Chapter session. Look forward to seeing you then. Thank you, everybody.